All right, let's start. Good evening, everyone. Welcome to our seminar series. Thank you all for joining us tonight. It's my great pleasure to introduce our speakers tonight, Agastya and Rohin. Okay, thank you for joining us. Rohin and Agastya are both outstanding students who have received many awards, including gold medal in last year's International Olympiad in Informatics. I believe both of them have a lot to share with us. For example, how to prepare for a computing Olympiad, how to improve programming skills, how to succeed in high school, and so on. So without further ado, please join me in welcome our speakers, Agastya and Rohin.
Hi. Yeah, so I think I'll go first. So to start off, I'd like to tell you a little bit about myself and my journey to getting to the IOI. So I started out doing competitive programming in 8th grade. However, at that time I had known programming before. I learned how to code. I started learning how to code in 2nd grade, but obviously I wasn't that great then. But in 8th grade was really when in 7th and 8th grade is really when I started to try competitive programming specifically for the first time. And that also happened to be the year where COVID struck. So I had a lot of time on my hands because school was online and I didn't have to spend as much time in school because I was in middle school and I spent all of my day at home. So I used to spend a significant portion of my free time and my class time doing programming. So I started late 7th grade, right before the US Open contest. And then throughout 8th grade and throughout summer of 7th grade, I spent a lot of my time practicing. And then eventually I was able to qualify to gold. I ICP to gold in December, then I ICP to plat in Jan, and then I made camp at the end of that year. So then after that, so that was my first time camping in 8th grade in the online year. And then after that, I was a Holstein for 1 year, and then the next year, this year, I made Iowa, and I won a gold medal there. So for me, so I'd like to start off by explaining why I made the choice that I did and why I chose to pursue competitive programming, and what kind of benefits it had for me to maybe encourage you to spend more of your time and effort to devote yourself to it. So for me personally, I think the thing I enjoy the most about competitive programming is the problem solving aspect. And of course, the little green accepted that comes up after you solve every problem. That's the most important part. But aside from that, I think solving the problems is just satisfying to me. And I genuinely enjoy that process, apart from the contest, apart from the system, everything. Just being able to break down problems and take something that seems impossible to solve in maybe even exponential time and eventually maybe cut it down to linear time. I think that that problem solving process where you can keep coming up with new observations and the problem becomes more and more doable. I think that's really satisfying and enjoyable. And so this is really what got me started. In fact, at the beginning of 7th grade, I tried a bronze contest and I did well in the contest, but I thought it was really boring and I quit. I quit for a year. But I think once I convinced myself to start again and I started working on the problems again, I kind of realized the satisfaction you get from solving a problem. So I think being able to derive that satisfaction from breaking down problems, maybe finding a problem style that you like, things like that. I think that's really important to keeping yourself motivated and feeling on your journey. And for me personally, that's what kept me going. Um, so aside from that, competitive programming since then has had a pretty big impact on my life. It has been probably my favorite hobby since 8th grade, and that is I do consider it a hobby, by the way. For me, it's something I do for fun, and then all of the other benefits are add on and they're more motivation to spend time on it. But I think it if you can motivate yourself and if you can find it enjoyable, that'll help a lot. But the standard response you hear for why you should do competitive programming is that colleges love you might have seen the graph of the stats of campers and what percent of them go to MIT. Colleges love it, and then for job interviews, it's pretty helpful later on because job interview questions tend to be just easier versions of competitive programming problem. But I feel if you speak to most people who end up at camp and IOI at the highest of levels, a very good percentage of them, probably most of them, just do competitive programming because they enjoy it, and everything else is kind of an add-on. Even though it might be the reason you start, I really want to stress how important it is that you enjoy it along the way. And it's had an impact on my life aside from just the fun I have from solving problems. I've even though it seems like it'd be kind of a sad hobby that you do by yourself, I've made a lot of friends through it. In 8th grade, most of the people I talked to, because it was online. So like a good percentage of the people I talked to were like friends I made who like did competitive programming with me, and I'll touch more on this in a bit. But like I think in general it has had like a pretty positive impact on my life because of the friends I was able to make along the way, and just in general like I think the things that I got from it. So like the problem solving skills. Um, so like aside from that, like on the second point, I think the problem solving skills that you get from competitive programming are like extremely like useful and applicable to like things outside of it. For example, like you hear a lot of people saying that, oh, like I did competitive math before going into competitive programming and that helped. And while that is true, I had the opposite experience because I never really liked math that much. But after doing competitive programming, I was able to develop a lot of the like similar skills like that you use in math, particularly like combinatorics and like probability. Those are like pretty similar to problems you see in competitive programming. So I was able to get a lot better at math just by doing competitive programming. And that's just an example, like even though that's also competition, in general, you see a lot of people, like once you are able to solve these problems, you see a lot of competitive programmers go into like quant after college or like go into like groundbreaking fields because of like the skills they're able to develop while solving these problems. So for me, like I like to think of it as like by solving these problems, like not only are you learning specifically like, oh, how do I apply Dijkstra? It's more like how can I figure out like how to apply different things? Like it's not it's more about like the process of learning how to draw the connections rather than like the specific like connections in a single problem, if that makes any sense. Like I think by solving the problems, the benefit is more in like the improvement you have in your problem solving process um than like being able to solve any specific problems. So like now I'd like to spend a little bit of time on like advice for people trying to get into competitive programming and like how to be successful in your journey. So first I'd like to start off with things that are probably not talked about as much that I think are really important, and then I'll go to the standard like how do you practice things like that. So first, I think one thing that like really helped me was just having people to like go on like the journey with me and like people to support you or like practice with you, like compete against like friendly competition. I think all of these things are very helpful. And like for motivation, at least they were for me. And like for example, as I was mentioning before, like within this like competitive programming community, which is a big part of the subject, like there are a lot of people on, for example, when I was in 8th grade on the East Coast Discord server, I don't know if I can vouch for the quality of the server anymore, but like back then, the people there, like they were like pretty good friends of mine, and like I met them and I got to know them, and we used to like practice together, solve problems together, like see how well each of us were doing on competitions and things like that. Finding a friend or like a practice partner to like do competitive programming with you, it's a really good way to keep yourself motivated and to have more fun. For example, there are also things called like lockouts, which are like 1v1 competitive programming competitions where like you have like 5 problems and then it's like a 1v1 format instead of like a big contest. And things like that are really fun. And I think that's another way to find yourself, like to fuel yourself, like the competition in itself, even if like the problems itself aren't appealing to you. But in general, I think those like that's a really good way to like motivate yourself and like improve. If you can like find people to do with you, it like even though it doesn't seem that important, it can like help you like gain more from your practice. So like the other thing that I'd like to say is like don't like force the issue always. Like for example, like if you tell yourself, oh, I'm going to practice like 6 hours today, and you're tired after two, and like what happens to a lot of people that like I've seen is that like after like those 2 hours, they're telling themselves, I've got to keep practicing. I told myself I'll do it for 6 hours. I have to. But then like they stop getting as much out of their practice because all they're doing is forcing themselves to like tell themselves that they're practicing, but they're not. So like it's one thing to like build endurance. Like that's fine. But like my point is like if you constantly force yourself to practice and you constantly force yourself to like do the subject, it's a lot harder to get things out of your like out of the like the problems that you solve. Like you will like it's like from my experience, what I found is for most people, they just like gain less out of like each problem that they solve. Even if they are able to like eventually read that editorial and solve it, like you learn less from each problem. And I think that is also like less touched upon by people just like maximize the learning from each problem. And I think that's really important. Like solving problems is always like the standard advice that everyone gives, but like everyone solves problems, but like what really matters is like how much you're able to get out of each thing. So like for practice strategy, so there's like 2 parts to like prepping for USCO competition. One is the like prior knowledge you need of like data structures and algorithms, like standard things such as like DFS, like binary search, like the things that you need to know, like the building blocks of the problems. And then after that, there's like the ability to connect the different building blocks together to like eventually solve a problem, like find observations and string it together. So the first, even though like, so for me personally, I never used like USICO Guide because it didn't exist when I started. But like I've seen like the quality of the resources, and like I've gone through like all of the lower division modules as well, and it's a really, really valuable resource. It's one of the highest quality like collection of like lessons and problems out there. So like I'm a strong proponent of using it to learn the topics. And along with this, if you're prepping for USICO in particular, like solving past USICO problems is essential. So as like I said like 10 seconds ago, USICO Guide, I like encourage using it to like learn the topics. And because the thing is separated by topic. So what a lot of people end up doing is like they go through the USICO Guide topics, and then they'll solve every single problem listed on every single topic and they'll be like, yeah, I'm good. I don't think that this is sufficient, because it's also really important to be able to like recognize what topic to use. Like, for example, if you know a problem is binary search, sometimes that's a big hint towards its solution. And in a contest, you don't get like the header binary search above the problem. You don't get to know what topic it came from. Like, you don't know what USICO Guide would have classified it as. So I think USICO Guide is a really, really good resource to like learning the topics, because they'll give you like a collection of different like possible resources, like maybe video lectures that you can watch, or like articles online, depending on like whatever learning style you prefer. And will have problems that you should practice on, because the only way you can tell if you really learned something is if you can solve like problems of that type. But I'd really like to stress the importance of practicing outside like of topic-based things. Like I think that if you know the topic beforehand and you're like practicing like topic-based, that's more of like learning the topic than it is like practicing. Like I like consider those two different things. Like one is like building your problem solving skills, and the other is like building your like background knowledge about baseline topics. So and like I like to like kind of imagine them as separate. So now like going on about like what problems to solve. So if you are doing topic-based things, like USICO Guide is like a good go-to, and they like classify problems as like easy, medium, hard, or whatever. But aside from that, like there are past like USICO problems that like those should be like your main source of like practicing if your goal is to make it to USICO. Like, because like past USICO problems are representative of what future USICO problems would be like most of the time. That's not always true in recent times, but for most of the time, like practicing from past USICO problems is like a good way to get better at the future ones. However, there are other online judges, such as like Codeforces and AtCoder, that also have really high quality problems sometimes. And so like I also recommend like solving problems from different judges, because especially if we look at like more recent bronze and silver, the problem styles are becoming more and more like observational, which and like becoming closer to the styles that you see in like Codeforces and sometimes even AtCoder. So I also recommend like going to like, for example, like my favorite judge is probably Codeforces. I think I practice the most on there. So I think like doing Codeforces problems and doing Codeforces contests, it's also a great way to practice. It's also nice about Codeforces, they have contests and they're like rated. So like having a rating is also a nice way to like track your own progress and to motivate yourself to like solve problems. So I like recommend and encourage like to try out like encourage people to try out different judges and like get a sense of the different problem styles. And on Codeforces, there are various features like tags and like also problem ratings that like make it easy to like guide yourself for what practice to do. And like the like for example, like something that I like recommend often is like just find the first Codeforces difficulty, which you can solve sometimes but not always. And then like that's a good level for you to practice, because like it's possible for you to solve, but you don't always. So like you can work on that to like make it like more consistent, so you can usually solve problems of the difficulty. So I think all of those features are really nice. And yeah, so like I like definitely recommend like trying out other judges and not just practicing on USICO. So in addition, like to talk about like more about like the learning side of things. So one thing that I did when I was like back when I was in like silver and like gold, I like when I solved problems, the way I learned things was if I like encountered like something that I didn't know, like if I tried to solve a problem and I couldn't, and I read the tutorial and I encountered some topic that I just didn't know, like I just Google it and learn about it and solve other problems of that topic. And I think this strategy, like it's pretty logical, because the topics that appear the most, like that way you end up seeing the topics that appear the most, because if you solve past problems and let's say binary search appears like 10 out of 30 problems, like you'll see it 10 out of 30 times, and then like you end up solving the topics, end up solving problems of the topics that occur more frequently. So like logically, like that's a good thing to do. You want to practice the things that occur frequently, so like you're more likely to have something that you're good at, you know. So I think like using past problems, as I said, like past problems are generally representative of what future ones will be like. So using past problems and like and if you don't know how to solve something, just looking it up and learning it from there, that's also like a very like useful way of solving or of like getting better. And also one thing that is pretty useful is virtual contests. So me personally, I never did that many. Not because that they're bad, and I like strongly believe that they're like very beneficial while practicing, just because I found it hard to allocate like big chunks of time to do a contest. But if you don't know what a virtual contest is, basically you just simulate doing the contest. So like you take some past contest. On USCO, you kind of just have to do it manually with like a 4-hour timer, but like you just take some past contest and then do it and simulate the contest environments. Like no outside Googling, spend all of the time on the contest, things like that, and then see how you do. And this is beneficial for multiple reasons. One, you can kind of get a sense of like how well you're doing on the contest, and you can kind of get a sense of like what to expect on a contest. Two, it lets you like it helps you make sure that like you can stay like motivated throughout the 4 hours, and you can stay focused, and it like builds like endurance. And the like more virtual contests you do, the more used to you'll be to the contest experience. And then it's just in general, it's just like a useful way of like you basically get to do it's like in terms of improving, it's like the same as doing a contest. So you also get like the idea of like contest strategy, like all of these things that happen only during contest time, you can kind of do it during your practice as well. So virtual contests on Codeforces and AdCoder and most judges, like it's like there's a feature on USCO, you just have to like set a 4-hour timer and like solve as many test cases as you can. But they're like a really nice way to like practice and like get yourself used to the contest environment. Yeah, so the last thing I wanted to talk about is like contest strategy, because I think this also isn't discussed like that often, especially to like newcomers. So for contest strategy, like for people who just enter USCO, like it seems kind of daunting. Like there are 3 problems, they're not sorted by difficulty. How do I know what to solve? And oh, like you can also go for subtasks. So like my strategy has always been just at the beginning of the contest, read all the problems. And like I'd like to stress how important this is, because problems are not sorted by difficulty like ever. So like if you read the first problem, even if like you think it's like interesting or whatever, just read all of them. Just so like you can get a sense of what all the problems are. And then after that, like thinking about each of them is nice. So what I do is I pick the one that seems the easiest or like seems the most interesting to think about, because like whichever I just think is like the most tractable, and then I go for that one, and then I think about it for a bit, and if I stop making progress or if I feel like I've wasted too much time on it, I switch around. And I think like being like switching around between the problems is pretty useful, because it's like really like what could happen is you sink all of your time into the hardest problem, and then you'll just like and just not solve the easy subtasks on the other 2 problems. So like for example in and which also which happens often, like which is very possible if you misjudge the difficulty of a problem. Like for example in IOI 2023, this happened to me in like both days. I think I spent a lot of time on the problem that I couldn't eventually solve, but I thought it would be the easiest problem. So I spent a lot of time on it, but at some point like you have to like cut your losses and move to the other problems. And like it ended up working out, but like it's really important to like try on every single one of the problems and not just assume that something is easy, assume that something is solvable, and just go for that one all the time. Now there's also like subtasks, and with subtasks like the strategy varies a lot. So what I tend to do is try to think about the full solution, but reading the subtask is also something that's extremely important, because the subtasks are almost like hints towards the solution sometimes. For example, like in tree problems, you'll see like subtasks where, oh, like the graph is a line, or like, oh, the graph, like all the degree is like at most 3, or like, oh, like it's a binary tree, things like that. So those type of subtasks kind of motivate you towards the solution, because by like the setter saying that, oh, this is like an easier version of the problem, like you have an easier version of the problem, so you can first work on trying to solve that and then try to extend that to the full solution, and that's like often helpful. So like my strategy for subtasks and like in contests is go for the full solution and then like read the subtask, and at some point, like if I feel like I'm really far away from the full solution or like I'm running out of time, just code the subtask and make sure to get all of the possible points you can get on the subtask. So like allocate some time at the end of the contest to like if you can't get the full solution, just do that. So a lot of like this just depends on like what you feel like, how long things will take. And obviously that's impossible to estimate, but like this is where like doing virtual contests becomes really important, because it kind of gives you like a sense of like how to develop the strategy. Yeah, so I think that's all I had to talk about. I think we're doing a Q&A session after both of us speak. So if you have any questions, we will do that then.
Thank you. Thank you very much. Guess Agastya, are you going to go next?
Yes. Let me just share my slides real quickly. All right. All right. Hello. Yes. So this is my presentation. My slides are gonna be very minimalist. Don't worry. It'll just be a nice title and maybe some pictures. All right. So, who am I? My name is Agastya. I am a junior like Rohin, and I go to Gunn High School, which is in the Bay Area. So this picture that you see here is of the 2020, what was it, 2023 IOI team. I am the second from the left. Last year we went to the IOI and I won a gold medal. And so I want to start by telling you a little bit about what competitive programming is first. So one thing that I want to emphasize throughout this talk is that the key to competitive programming is enjoying it. Even if you do not enjoy it now, I think there is something in competitive programming for everyone, and that I think that everyone can enjoy competitive programming. I started out not actually enjoying competitive programming. I was doing it only for college, but I've now gotten very far and I enjoy it immensely. And so I think the main thing that is important is to try to enjoy what you're doing, and I think that everyone can do this. So the reasons that I like competitive programming are because each problem feels like a puzzle. I feel like each problem is like a video game. Like it's something you do because you don't want to do something else. It's distracting. It takes your attention. You can't do anything but think of it. And so whenever I see a competitive programming problem, it doesn't feel like I'm working to solve it. It feels like this is something that's fun and that there is nothing else I'd rather do. I don't want to play Minecraft. I want to solve competitive programming problems. But I think that everyone has their own reasons for wanting to do competitive programming, and I think a lot of people enjoy it for very many different reasons. And I think these reasons are intensely personal. There are, of course, obligatory many academic benefits. So as I mentioned, I started out doing competitive programming because I thought it would help me with my college journey. Many people also use it to prove that they can actually code. But I do want to stress that I think that the most important thing to make sure of if you want to get into competitive programming is that it's something you enjoy. And even if you don't enjoy it yet, I'm confident you will in the future. So what is competitive programming? Competitive programming is a math contest with a computer. So what this means is it's like you're trying to solve a problem. There are some numbers given to you in the input and you have to find some output. But instead of having to do all the calculations yourself, you have a computer to do the grunt work for you. This makes it much more interesting than math competitions, in my opinion, because it means that instead of being limited to problems where a human can feasibly do all the computations, we can do things that are much more complicated, involving billions of operations in less than a second. So now I want to talk a little bit about my competitive programming journey. So I started to learn how to code in 4th grade. I was learning JavaScript and Python, and I only started competitive programming in 6th grade. I studied over the summer leading up to 6th grade. In my very first contest, I managed to make the silver division of USECO. And then at the end of the year, I managed to barely make the gold division. The next year, I actually did not do anything at all. I prepped a lot. I took all 4 USECO contests, but I did not get to the next division. And then in 8th grade, I was able to make the platinum division. Then in the next year, I was invited to the USECO camp, and last year I was invited to IOI. So for me, competitive programming has always really been synonymous with USECO. I haven't really done competitive programming seriously outside of the USECO progression of the 4 monthly contests and then the camp and IOI. But I do want to stress that competitive programming is really fun, and if you are enjoying it and you are preparing for USECO, that you can still do other competitions. There are lots of competitions around the world. There are online competitions. In fact, MIT IT is tomorrow, and next week there is the Calico competition as well as the Basis online competition. These are all online competitions that you can participate in from anywhere. So if it is something that you really enjoy, I think just consider giving it a chance and participating as often as you can. Now, throughout my competitive programming journey, one thing that I really regret that Rohin brought up is that, at least at the beginning, I didn't really know anyone doing competitive programming. In fact, I went through bronze all the way up to platinum without knowing a single other person preparing seriously for the USECO. And it wasn't until freshman year when I discovered my school's small competitive programming club that I started to meet other people who were also doing this activity. So I think that this is something that I regret a lot. Every weekend when I would do USECO, it used to feel like somewhat of a struggle because I felt like I was just alone in my room coding. And while it can be that way sometimes, I think it is a lot more fun if you have people who you can chat with, maybe in person or even over Discord, to make the experience a lot more rewarding. And now before I move on to the rest of my talk, I just want to clarify that competitive programming is a very personal activity and that there are a lot of strategies that work for a lot of people. I know some people who open the first problem and don't go on to the next one until they solve it. There's people like me who go very aggressively for subtasks. I know some people who do nothing but take virtual, some people who just practice whenever they feel like it. But I think that the only constants are, one, you should be interested in it. And again, this is not something you have to be interested in now. You could develop an interest through your practice. And number two, you have to engage with competitive programming. And I think besides this, nothing else is a constant. But if you do these two things, you should be fine. But my advice will maybe help you do these two things a little bit more. So first, let's just talk about in-contest strategy. So this is that you are actively taking the contest. What can you do to maximize your score? The first thing is that this strategy is, again, not universal. My strategy is very different than Rohin's, but they both work as long as it's something that you are used to. So what I would recommend is being very aware of subtasks, especially if you're taking USACO style contests. So these are like easier versions of the problem that are given in the problem statement that you get partial credit for solving. And so your contest strategy is centered around solving problems, but it's about really at the end of the day about maximizing your score. So at the beginning of the contest, you want to be optimizing for solving problems, because when you solve a problem, you get way more points than when you solve a subtask. So you should start always by reading all of the problems. And even in contests that are ordered by difficulty, like code courses, I like to very aggressively skip problems. So if I think that a problem is a little tricky, I'll just immediately read the next problem, because problem difficulty is very subjective, and you should always make sure that you are doing the problem that is easiest for you. So after you've read the problems that you want to think about, you should start with the most approachable one. And then, like Rohin said, you want to make sure you don't get stuck. So I like to switch every 30 minutes or so. I find that actually if I spend two like different 30-minute chunks, I'm much more likely to solve a problem than if I just spent an hour on it, because I'm able to try new strategies. And this is also really important because it means that I'm not sinking all of my time into the impossible to solve problem. Now, where my strategy is going to be a little bit different than Rohin's is with the subtasks. I like to implement subtasks super early. So around an hour and a half before the end of the contest is when I like to start implementing subtasks. So this means that around an hour and a half before the end of the contest, I'll be looking at the subtasks, seeing which points I know how to get, making my plan, and then I'll start implementing them. And the reason I do this is twofold. Now, one of these issues is very unique to me, which is that I'm a very slow typer. We were actually at the USACO camp this year. We were playing Type Racer, and I was consistently last place. So if you're like me and you cannot type fast, then make sure you allocate time for subtasks, because more than any other part of your contest, your subtask solving speed is governed by your typing speed. And the other reason I like to do subtasks early is because subtasks are not really wasted time. When you implement a subtask, that subtask is likely going to help you towards the final solution, and the code you write could very well be reused in the final solution. So anything you do while solving subtasks is not wasted time. And there have been so many contests where I try to convince myself that I'm going to solve the last problem, or the second problem, or the first problem. And almost every time, I think that I'm very close to the solution and the time runs out and I haven't implemented the subtasks. So the gain from implementing subtasks is huge. It could be up to 40 or 50 points, or in fact, if you're at a big contest like the International Olympiad Informatics, it was possible to pretty much get a very solid gold medal score without fully solving any problems. And so it's really important to get all of the easy points that are available to you, especially when they come at such a low cost. So that's my bit on in-contest strategy, but a much bigger part probably of your coding experience and journey is going to be what you do outside of contests. So again, this is very personal, and as long as you are interested in competitive programming and you are practicing somehow, you are doing things right. But some advice I have is do problems that are fun for you. Now, there are some exceptions to this. Even if you hate doing combinatorial problems, if you're looking to score well, you still have to try them occasionally because they will appear on contests. But I think that a good metric for whether a problem is good or not is whether it's fun, because at the end of the day, learning is just about engaging. And so if the problem is a little bit easy for you, but you're still engaging with competitive programming for 5 minutes and coming up with new ideas, and that problem is fun for you, then you are learning from that. And likewise, one of the most rewarding experiences for me has been looking at problems that no one solved in contests that are clearly too hard for me to be working on, but I work on them anyway, and sometimes I solve them and sometimes I don't. But I'm just thinking about these problems because they're so fun to me. And so if you look at the problems that are fun, you're guaranteeing that the time you spend is used effectively. Now, if you're not really sure and you're just browsing for problems, then as Rohin's recommended, I would look at problems that are a little bit above your skill level. So you are solving maybe around half of them. That is a good way to make sure that the ideas are new to you. But if you're able to, then using problems that you think are fun is also a good way to make sure that the problems you're choosing are interesting and new to you. Now, I don't want to get too into the weeds on specific resource advice. I think that just for me, what has worked is Code Courses blogs. There's never been a time where I've been curious about some concept, about some data structure, some algorithm, and there hasn't been a Code Forces blog written on them. Code Forces is a huge community with 20,000 people taking any given contest. And so if you're curious about a topic, there's probably a Code Forces blog on it. You can also check websites like Geeks for Geeks, and especially now, USACO.guide is a good way to fill any holes in your knowledge. But I think the main thing to do is to just not worry too much about whether what you're doing is completely optimal for practice, because whatever you think is the most fun is probably right for you. So for solving problems, there are lots of sources. If you're at a higher level, you can consider looking at other countries' national Olympiads. You can find these by going to oichecklist.pythonanywhere.com. But you can also look at past USACO problems. They're a great source of fun problems and Code Forces problems. And there are lots of great sources of problems, and I think just choose whatever is at the right level for you and what is fun for you. So that's all of my problem solving advice. Now I want to talk about time a little bit, which is that in addition to doing USACO, I do take my schoolwork very seriously, but I just want to say that USACO and school are very much compatible. 1 second. So actually, last year when I'd already made camp once, and I was hoping to go to camp again. I was trying to train. One of my favorite things to do would be to just open my phone, look at a problem I thought was interesting, and think about it whenever I had time. So maybe when I was walking from a class to a class, or when nothing was happening in class and the teacher was preparing for the lesson, pay attention in class. Don't do competitive programming when your teacher is talking. Or maybe when I was just waiting for my parents to pick me up, I would just think about a problem. And I'm not saying that you have to make sure you're using every ounce of your time wisely. It's just that I was bored a lot of the time, and competitive programming was fun for me. So I thought that if I can just do competitive programming whenever I'm bored, then I will never be bored. And this has actually worked remarkably well. Whenever I'm bored, I just open Code Forces, look at a problem, and I read it, and I think about it, and I'm no longer bored. And so what I need to say by this is that time is probably not a huge issue. You do eventually need to be able to, you have to have time to take the contest, and you do need to practice coding. So you do need to have time to sit down and code, but you can get very far with way less time than you think, because these things are all compatible. There's dead time everywhere in your schedule, and USACO is something that can vary. In competitive programming is something that can easily fill that dead time just by looking at and thinking about problems. And this is where my bit earlier about competitive programming being fun and fun being important comes back into play, which is that if competitive programming is fun for you, then you don't really have to worry about practicing, because if you're having fun, you are going to automatically practice. So yesterday, I told myself that I was going to come home from school and I was going to read a few chapters of my AP US History textbook, and I was going to take some notes on them to prepare for the AP exam in a few weeks, as well as our quiz next week. Now, what I did instead is I opened a past camp contest and did a 4-hour virtual of it. And the reason I did that is because competitive programming is so much more fun for me. Now, I'm not advising you to not do your homework. What I'm saying is that unless you are truly at your limit, you can do competitive programming if it's something if you find fun. You do have time for it if it is something you truly enjoy. So what I would urge you to do is just try it and see if you enjoy it. Because if you do enjoy it, it is something that will just make you less bored and will give you something to do at all times of day. And you don't have to think of it as practice. It is just what you can do instead of playing video games. You can tell this to your parents, by the way, as well. All right, so finally, I want to talk a little bit about how to start. As I've said, the most important part of competitive programming is your enjoyment of it. And what I mean by this is really your motivation. Like, how much do you want to code, and how much are you itching to do competitive programming? Because my advice is very personal, and my contest strategy is very personal. My copious taking of virtual contests is very personal, but motivation is something that is very universal. So I would encourage you to just find a way to be motivated. And if you cannot be motivated while doing competitive programming, that's okay. But I think even if you don't enjoy it now, you will enjoy it if you start and you try and you treat it as something that is supposed to be fun, because I think everyone loves puzzles, and so everyone can enjoy competitive programming if you take it as an opportunity to just have fun as opposed to something you think of as work. So motivation, again, it's not innate, but it is important. So as for how to start, here are my 2 go-to websites for problems. This bottom left logo is the USACO logo. So past USACO problems are a great way to practice. And this top right is the Code Forces logo. Past Code Forces problems are a great way to practice. And so how to start is to just start. Of course, if you need to learn how to code, there are great tutorial videos. You can start by learning C++, which is the go-to programming language for most competitive programmers, or you can start with a more beginner-friendly language like Python. And then you can just start opening problems and trying to solve them. And even if you're not able to solve problems at first, as long as you are having fun, you will improve and you won't have to think about practicing so much. So I think that it really is simple to get started. There are lots of more specific things that you will have to figure out eventually. You will have to figure out what content setup you use. So for example, to code, I use what is essentially a fancy text editor, which is called Sublime Text. And I use the command line to compile and run my programs. I know some people use tools like VS Code, which has a nice debugger. And some people use Vim, which makes the text editing process much faster. But I think that these minute details are not what you need to worry about when you're getting started. I think that for getting started, the most important thing is just to find that you enjoy problems and to find problems you enjoy and just start solving them. So thank you. That's all I have for right now. I think we're doing a Q&A now.
Right. Thank you so much. All right. Any questions? Would you share what coding classes you took before you started coding competition? What math knowledge, you have when you start coding in your 6th grade? Did you finish intermediate algebra?
Okay, so I'm sure me and Agastya will have very different answers for this, but I never really took any formal coding or math classes. Everything I learned myself through like free online resources. So that is to say, like, I did do like Code Academy in like 2nd grade, and it was just like a free like online tutorial or whatever. But like I hadn't taken any classes at that time, or like ever. However, for like math knowledge, I had done like math competitions in 5th grade. However, like I was not very good. Like that. I did like participate because I wanted to try it out, but like math was never really my main focus. So I will say that having a math background, like although it's definitely helpful, it's not necessary. So like I still tried competition math and I still like enjoyed problem solving beforehand, but it wasn't like a big part of my like life or like my school life. Did I finish intermediate algebra in 6th grade? Is intermediate algebra 2? I think by 6th grade I'd done pre-algebra. I don't think I did anything else. Maybe I did algebra 1 by then. But yeah, like especially like algebra, like the school math courses, I think those are like it's not that helpful for competitive programming. Like algebra isn't necessary sometimes, but like it's pretty rare, especially compared to like combinatorics and like geometry, for example. It's unlikely that you'll see like algebra problems. So I also don't think that that's important. Yeah, Agastya, do you want to answer that?
Yeah, so I also did not do much in terms of formal classes. I was very lucky in that my dad knows a lot of coding and a lot of math, so he has taught me a lot of what I know. In fact, like all the way up to platinum. In fact, he was able to help me through data structures, and I would definitely recommend looking online as well, because this approach meant that I only had one source, and so I pulled up to camp knowing what a segment tree is, but not knowing what a Fenwick tree is. So I would very much recommend that you do use online resources as well. But I think that classes are helpful, but not necessary. I think that it is possible to get anywhere you want to go with just what is online. In terms of math knowledge, I had started doing some math competitions before, but I've always been ahead in coding competitions compared to math competitions. By the time I first qualified for the Amy in 7th grade, I was already gold, and so I think that math competition knowledge was not a big part of my journey. I think that at some point there will be a requisite math knowledge. A lot of problems do require some mathematics, but I think that you shouldn't worry too much about trying to learn math as a prerequisite to coding, because as Rohin said, it's very possible to learn math through coding as opposed to the other way. And finally, did I finish intermediate algebra in 6th grade? I took algebra 1 as a 6th grader, so I guess not.
All right, next one. I'm in 7th grade and about to Amy and use Silver. What should be my next steps? I'm not sure what to do.
Yeah, okay, I can start. If you're already in like Amy and Silver, you've definitely got a good start, and I think like you're already like more advanced than I was at that time. So like you're already doing pretty well. I'd like to say that. For next steps, so like I think USCO Silver is where a lot of people start struggling. It's one of the big roadblocks because, well, now bronze is also like pretty hard, but if you go back like 5 or 6 years, like bronze used to be just like, do you know basic algorithms and like basic coding? So I think the advice that I said earlier during my talk is like pretty applicable here. Just like solve problems, like learn the topics that you need to for USCO Silver. Like by solving problems and Googling, and then also like maybe going through USCO Guide, and like just solving like pretty much like what both of us said in our talk about like solve problems and try to like enjoy the problems you solve and solve problems that like suit you, and just working that way like will probably like I think those are just good next steps.
Could you briefly explain the points scoring system for USCO?
Yeah, so the USACO system works as follows. There are 3 problems. In theory, they on their website they say that there are 3 or 4 problems, but I've never seen a contest that is not 3 problems. These 3 problems are not arranged in increasing order of difficulty. They are alphabetized, and each problem is worth an equal number of points. However, unlike other competitions, the USACO uses a test case system. So each problem is worth an equal number of points, and each test case of that problem is worth an equal number of points within that problem. So if a problem is usually worth 333 points and there are 10 test cases, then each test case is worth around 33 points. And then there are also subtasks, which are just some test cases that have easier constraints.
Okay, next, how much time should I allocate toward USCO each week if I want to get to platinum in around 2 years?
Okay, so this type of question is really hard to answer because it depends very strongly on like how much you're able to get out of your practice, and just like it like depends on so many factors like luck. Like it's just really hard to say. Like me personally, like I don't even know how much time I spent on USCO. And like it also depends on like background, like what you've done before, like your current skill level. There's just like so much to say. Like there's so many things that matter. It's kind of impossible to tell. And like I'd also like to say that there's no like specific formula for like how long it'll take to get to a level, or like how good someone can be with some amount of time. Like it differs based on like person to person. So like I know this was kind of not like very helpful of an answer, but like I think spend your time, like however much time you have. If like doing well in competitive programming is your goal, just spend that time devoted to like the practice strategies we recommend. Like you could try those out. Just like see how well you can progress. Over time, you can see how like fast like you're getting better, and then you'll probably be able to make a better estimate than I can. Like for you, but like I just don't think there's enough information to be able to give like any sort of decent prediction.
All right, next question, online resources you can share. I think they just shared basically usco.guide, usco.org, code forces, anything else?
Yeah, I mean, resources generally fall into 2 categories. The first is for learning new like tricks and algorithms, and the other is for problems. For problems, I think that for pretty much every contestant alive, if you just use USACO and code forces, you'll be fine. But if you are looking for other problems, you can use AdCoder, you can use TopCoder, CodeChef. There are really many sources, but I think that for now, I'm not exactly sure where you are in your trajectory, but I think that starting with USACO and code forces is a solid way to start. And then for learning new tricks, as we said, USACO.guide is a fantastic resource. And if you're like looking for a specific tutorial on a specific trick, then just Googling that will give you a nice Geeks for Geek article or a Code Forces blog that will probably be good.
Okay, next one. Which Olympiad do you favorite? I guess is your favorite. Which Olympiad do you think has nice problems and recommend for useful practice? Sure. Yeah.
Okay, so I think like my favorite Olympiad in terms of like problem quality and stuff is probably IOI. Like probably unsurprisingly, because like it's like the most prestigious one. So you'll see like the best problems from like a variety of authors and like very different like problem styles in IOI. So I like those a lot. My second favorite besides like USCO and IOI is JOI. JOI, however, like the problems are like really hard. So like they're pretty much comparable to IOI problems. Like the difficulty, and some of them are probably like harder than most IOI problems. But I think like the problems are often really nice. They're often also data structure heavy and like as I said, quite difficult. But like if you are like a plat level contestant or like camp level or like IOI level, like I'd recommend trying out JOI. I think the thing about these Olympiads, like the international ones, is pretty much all the countries I've seen, like most countries I've seen, don't have like a bronze, silver, gold, plat type thing that USCO does. So it's not really suitable for people outside of the platinum division because they're kind of made for people like competing to get to IOIs, which is like people of like the platinum skill level. So like yeah, so like those would be like my favorite. So for skill practice, if you're doing plat, like pretty much all Olympiads are pretty good. Like like Canada's is also pretty good. Like the BOI is also good. Like Baltic, like COI like is often like sometimes has good problems. And then like APIO, like all of these are like a lot of like the Olympiads you'll see will be pretty good. But like as I said, they are generally for plat level practice. So if you're in plat, like I would try like pretty much any of these. They're all good sources of problems. Otherwise it might be kind of hard.
Right. Next one, if I'm already familiar with Python, when should I start learn C++? How far can Python get me? What do you think?
Yeah, so I'm of the belief that with Python, you can get all the way to the USAC camp. And the only reason you cannot go farther and get an IOI gold medal is because you are not allowed to use Python at USAC camp. Actually, I don't know if this is true. You can go as far as you are allowed to use in Python. However, that being said, I think that C++ is a far more friendly language to use. So I started competitive programming with Python, and I was able to, in the open contest in my 6th grade year, I was silver, and I was able to make gold with Python. But that contest irked me a lot because the solution to the last problem used a balanced binary search tree, which is an extremely advanced concept, which is still pretty rare even at the camp level. But the reason it was used is because in C++ there is this there's a structure called a set, which is very easy to use and very beginner friendly. So C++ is just nice for a lot of reasons. It has a standard template library, which is pre-implemented algorithms, and it's also way faster than Python, which is another main reason. So I think that if you really want to, you can stick with Python, but I think that you should start learning C++ as soon as you feel comfortable with Python syntax, and as soon as you feel comfortable with like thinking about competitive programming problems, because it'll make you way faster, even though it's a little bit clunkier.
All right, thank you. Let's see, next one. How do you figure out what problem requires what algorithm?
So this is where a lot of like the practice and pattern recognition comes in. So in general, the way like you get better at solving problems, like people say it's practice, but like what practicing really does is it develops your pattern recognition skills. So you can kind of like apply what you've learned from older problems and say, oh, this is similar to something else I've solved. And like you can make like observations that way. A lot of times this process isn't exactly explicit. Like you don't remember a specific problem that you solved like 2 years ago, but you remember the general ideas and like the paths that got you there and like the connections that you draw. And this like that's pretty much how like you like solve problems and figure out what problem requires what algorithm. Like a lot of times, like for example, like a very common pattern you see in problems is like, oh, find the maximum of this function where the function is like a minimum of a bunch of things. And that tells you that like a very common thing in those type of problems is to use binary search because you can binary search over the answer and then all that like what you want to know is like make sure everything in every value of that function is at least whatever you're binary searching over. Like that's kind of a specific example, but like in general you just see like these patterns occur in problems a lot of the times and like you see like problems of like the binary search type have this pattern and like you kind of like develop this intuition. So there's no like specific process, but just solving problems is like how this like intuition gets developed.
Thank you. How did you find the time to do all the things you do? What other EC activities do you do besides coding?
Yeah, so I think, like I said in my presentation, coding for me is no longer something I have to worry about having time for. For me, it's something I just do whenever I feel like it, whenever I'm bored. Whenever I would be watching a movie, I'm instead coding. So for me, my time just comes out of my leisure time because I think of competitive programming as leisure. And some other things I do are I go to school and nowadays I spend less time doing homework than I used to, but I used to spend a lot of time doing homework. I take some math classes outside of school. Right now I'm playing tennis. I sing as well. And this year I started doing competitive physics as well. So I think that you can do many things. And I think the key about time is that you only need to have time to do the things you don't want to do. Because I think that the things you want to do take way less time than the things you don't want to do. As an example, when I'm reading my APUSH textbook, it's way harder than doing competitive programming. And so it takes way longer than it should. Even if I'm only actually spending an hour on a chapter, it takes 2.5 hours somehow. So I think that the reason I'm able to do a lot of things is because I enjoy most of the things I do.
I see. Actually, some parents ask, do you guys play games at all or not?
Okay, so I don't like I wouldn't consider myself like someone who plays a lot of video games. That being said, I do play like sometimes with my friends. Like I'll play mobile games or I'll play like like games like with my friends. I don't like personally, I just have never enjoyed playing video games by myself. I just don't find like much satisfaction in that. So like with my friends, like I do play things, but it's not like a big use of my time because I just like don't enjoy playing things by myself that much. So yeah, but yeah.
How about you? How about you, Agastya?
Yeah, I don't play games. What I do is I watch YouTube. I've been trying to watch less YouTube as I feel like it is not something I actually enjoy. And every time I watch YouTube, I think, oh, I would have enjoyed coding or whatever more. But I don't spend that much time on it, and I think that the reason is just because there's so many things that I enjoy more that I don't really do it. I do play a lot of games with my friends, but the games I play are generally not video games because my friends and I don't really play video games. We play a lot of board games instead.
Right. Okay, let's move on. I was wondering if you do lots of, do you do lead code problems? Would the lead code problems improve your ability for user code?
So I okay, so I did at the very beginning when I first started, I did do lead code to practice because I got frustrated with code forces because I thought it was too hard. So I wanted some like easier source of problems. I do think that lead code is not the best like place to practice because especially for USCO, because the problems you see in interviews are usually more standard than and like just easier than USCO problems and like they kind of have a different style. So like I think just practicing USCO and practicing code forces is a better use of time. Nowadays I do lead code contests pretty much every week because they give prizes for if you do well. But like in general, I don't think it's the best use of time in terms of practice. I think like any of the other sources we mentioned is like a better way. Lead code, however, is if your goal is to do well in coding interviews, lead code is like a pretty good source of problems because they're more similar to that.
Right, thank you. Let's move on. How do you guys get better at math?
So I'm probably not the person to ask for this because in addition to my doing competitive programming, I also did math competition very seriously. So the way I got better at math is the same way I got better at competitive programming. It wasn't a chore for me. I just like attended math competitions. I did math. I like my dad taught me some math. I did math by myself, and so I just treated it like any other competition. It was very fun for me, and so I just learned it. I think that a lot of people just kind of learn math through competitive programming, where you see a lot. Yeah.
Right. Let's see. When working on a hard, frustrating problem, when do you decide to give up and look at the solutions and implementation?
So a lot of people have different like advice and recommendations for this. So I think there's two ways to answer this question. One is what I do and one is what I think you should do. So I'll start off with what I do. Personally, like my attention span is not like the best anymore. So I usually give up like when I just start getting like frustrated with it and I feel like or like sometimes I'll just like open that tutorial and glance at it to make sure I'm not like there's nothing I don't know and then like I'll read like 5 of the words in there and then just keep going on from there. But I think like what I think you should do is like work on the problem until you just don't have any more ideas about it. So like at some point for some problems that are just way above your difficulty, like you'll just get stuck and there'll just be an observation that like it's just like really, really hard to find for you. And like you'll just stop making progress on it. And at that point, spending time on it is kind of wasting your time since you just like don't really you're not really gaining anything out of it. So something that a lot of people do is like they'll read problems and if they can't solve it, they just like don't read the editorial, they just like sit on it and like maybe like 2 months later try it again. So I personally never had the willpower to do this, and I don't think that it's necessary. I think just like once you don't have any more ideas about the problem, like it's okay to read the editorial. One thing that I do think is helpful is read the editorial like line by line, and then like every time there's like a new idea that you didn't know about already, just stop reading the editorial and see if you can like come up with the rest of the problem yourself. So that way, like if you're missing one part of the problems, you can still try to solve the rest of it by yourself. But just like in summary, just like keep solving the problem until like you stop making any progress, and then like if there are hints in the tutorial, you can like look at the hints. Or if there aren't, just like keep reading the tutorial until you encounter a new idea, and then like repeat this process. Like solve it, like keep thinking about it until you don't have any more ideas, and then like continue from there.
Next one. How about Java? Will it work for Platinum?
Yeah, Java is a great language too. Java is very similar to C++ in terms of syntax. In my opinion, it's a little bit less good because you don't have pointers and it's a little bit slower and there's this weird garbage collector thing. But Java works. I don't actually know the current status of Java for USACO. I know people have been very successful with it in the past. Notably, Danny Mitchell was able to use it to get all the way to the IOI and do well there. But I recall hearing something recently about it not being allowed anymore. I know at camp some problems are C++ only, but yeah, I'm not sure about the current status of Java. For Platinum, it will definitely work though.
Yeah, so I'm pretty sure. So you can use Java up to in Platinum. In camp, they don't let you submit in Java anymore because at IOI you can't submit in Java. Like they removed it. So like for most people, like Java's fine. Like just to add on really briefly, like Java's fine for Plat 2. There's like some problems, like very few that you just can't solve in Java. Like exercise from 2020. Pretty sure it's just not possible. But like in general, Java is fine. Like you might have a little bit of issues with time limit, but like Java is a lot better than Python still. So like C++ and Java is generally okay.
All right, let's see. Next one, you started to learn coding at a young age, 4th grade. I was wondering, how do you keep yourself feeling interested, passionate, and excited about coding? Have you ever thought about giving up because you have learned it for such a long time?
Well, I think that coding is like an important skill that almost everyone will learn at some point for some use or another. And when I started learning coding, it was just for that reason. Just coding, like it's something that's useful. You'll use it. I started coding in a completely like competitive programming free environment. I was just coding. I started by making a tic-tac-toe game with an HTML website. But then when I started doing competitive programming, I was able to keep myself interested because the problems are just interesting and fun. And so I just find it fun. And I keep myself passionate just because it's just fun. I have never had to feel like I'm burning out just because I think it was a hobby that's fun for me. Um, and I have thought of giving up coding once. I thought of giving up coding in 9th grade. Uh, this is after the USECO season. I had done somewhat poorly that season. I thought until the last contest in the Platinum division. And so I was seriously considering giving up because I felt like I was at a roadblock in competitive programming and that getting to the camp was really hard. I didn't know if was willing to spend another year doing it. I think since then I have enjoyed it more and more. Like my enjoyment of it has grown. So I think once you're able to really, really enjoy it as a hobby, you won't necessarily think to give it up just because you enjoy it so much.
Right. Next one, how do you balance coding time with your time at school?
Yeah, so I think like Agastya touched on this on his talk. I didn't really talk about this as much, but so like in general, like the thing that you probably got out of both of our things is that we both really enjoy competitive programming and it's not really work for either of us. And like as I said earlier, I like strongly believe that this is true for most of the competitors at like the top level. And so for like school, like once you like progress through high school, it becomes like a bigger and bigger time, like a bigger and bigger part of your life, I think. Like especially like second semester junior year and first semester senior year. But like I think so like coding, if you think of it as a pastime, it ends up being pretty easy to like work with like in school. Like if you don't have time because one day you're bogged down with a lot of school stuff, like it's a little sad, but like you can move on. But like in general, like if you're able to like it, I'm sure you like don't, I'm sure like pretty much everyone doesn't work all day. So if you take like the 45 minutes you wasted maybe watching YouTube or like playing games or like something else, like whatever like you think of your leisure time, if you can think of coding as like that same leisure time, like you can kind of replace it and you it's able like you would be able to find time. So just I think like what's important is basically enjoy competitive programming as much as possible, and then it becomes a lot easier to balance with your school time.
Okay, great. I still questions sent to me using direct message, probably from our parents. Does it have to be smart to do musical? Do you guys have high IQs?
Well, I guess first about IQ. What I noticed about IQ is it just seems to be like a math competition problem. So, like I have never finished an IQ test, and I took a few like halfway around like a year apart, and I noticed that each year it kept getting easier and easier. And this is because I was doing more and more competition math. And so I think that IQ is just like basically a measure of how much experience you have recognizing patterns, and has very little to do with like some sort of innate intelligence. Um, I think that there are very wildly different opinions on this. If you um if you don't value your sanity, you can go to Code Forces and look at the rants and debates about whether there's something innate needed for competitive programming. I personally think you can get like I don't know if you can be the best in the world. I don't know if, but I think that everyone can get essentially arbitrarily high and do like top 10 in the world with if it's something you really enjoy and are really willing to spend the effort for. So I don't think it's a huge factor, but I don't know if I can say that it doesn't exist.
Okay, thank you. Next one, do you play chess? Will play chess improve your coding competition ability, or is there any other easy activity would be helpful to improve your coding ability?
Okay, for chess, I played in elementary school, and then I was never too good. So I never played competitively or like after 5th grade. Nowadays I do play for fun. So like that is, and I do like follow chess. Like the candidates are going on right now, if anyone's interested. But I don't think that there's any relationship between chess and like pretty much any other way that people measure intelligence. If you talk to like good chess players, they'll tell you the exact same thing. Like for example, like personally, I think competitive programming is a lot more like way more generally applicable than the skills you get from like getting good at chess. The patterns you see in chess like will never show up like literally anywhere else in your life. But competitive programming is useful like at least in like a job or like math or like different like science disciplines or whatever. So I think like for chess specifically, I don't really think that there's a purpose outside of just getting good at the game. And like if you enjoy that, like sure, pursue it. So yeah, but like then again, I'm not an expert chess player. I'm just relaying the opinions that I've heard from like people much better than me. And then like for extracurricular activities that I would feel helpful that are helpful, I think practicing code word like doing coding is the best extracurricular activity for to get good. But aside from that, like just like as I said, like math and just other problem solving like things in that general area are like decent options. But like I think the best thing to do like if you want to get good at like programming is like to like practice programming. Like if you want to get good at something, like doing that is probably like the most efficient way of getting good at it. So I think yeah, like if you want to pursue chess because you like enjoy chess, not because you want to use it to get better. Like for example.
Okay, great. I see another question. My son struggles to go from silver to gold. Do you have any suggestions?
Yeah, so I also struggled from going to silver to gold. And as Rohin previously mentioned, I think the main reason is because bronze is traditionally, I don't know if this is true anymore, has traditionally been about just testing your understanding of syntax and maybe some basic algorithms, whereas silver is now about starting to understand like competitive programming, not competitive programming tricks, but just being able to make observations, which is what we call it. It's a new skill where you have to be able to reduce a problem down to something simpler or to understand something key about the structure of the problem. So I think that silver to gold is a huge jump, and you shouldn't feel disheartened if it's hard. I think the main thing you should do is just continue to practice problems that are above your level, so you're getting exposure to this new idea of having to deconstruct problems into multiple layers, and not just being able to directly implement what the problem is telling you to do.
Next one, how do you learn approach new algorithms?
Yeah, so the way like I've always learned algorithms, like I prefer like written things because I like to reread things multiple times if I need to think about it again. So the way I just learned them is like I find some like usually Codeforce's article on like whatever algorithm I want to learn, and then I just go through it, like read it, like see like reread the parts that I don't understand, and then like maybe go try solving a problem on it and try implementing it myself to make sure I understand all the details. But like just in general, like just like everyone has different like preferences for how they like to learn. Like some people prefer videos, and that's fine too. So like for example, as I said earlier, going on Usego Guide is like a really good way to find resources. They generally have different types of things linked, so you can go there. Just like Googling it and just finding out whatever information you have is like good enough for me. And like I think is good enough for everyone. So it should be like yeah, like that's like how I'd recommend.
All right, thank you very much. I think we answered pretty much all the questions. So what's your guys' plan for the future? To talk about it. So you both are end of your junior year, right? So yeah, what's the plan?
Yeah, I mean, my future plans are, I think, very packed right now. I think this is the time to, be preparing for USAC camp and to be wrapping up school for this year. And then I have a very packed summer, and then I come back and immediately write my college applications. And then second semester senior year, I'm not sure what I'm going to do. I'll maybe continue coding, and maybe I'll try out some other competitions and just do whatever is interesting for me. I will be bathing in the senioritis, and I won't really know what to do, I guess.
Wait, by future plans, did you mean like immediate future or like after college?
Yeah,
like...
both. So college and then beyond.
Okay. Yeah. So so I will be applying. Like we will both be applying to colleges this fall. So most likely I will actually like almost certainly I'll apply for CS because I think that's what I'm most passionate about. I'm like in yeah, like I don't know what else to say about that. Like everything is largely undecided because like obviously I don't know where I'm going. So yeah, but then like in the future, in terms of jobs, something that you see a lot of competitive programmers do is go into quant because like high salaries, but it is high intensity. So like I haven't really decided what I want to do past then. Like doing academia is also an option, but I don't know how much like I'll be willing. Like I don't know if I'll be willing to do that at that point in time, even though it does seem interesting to me now. So I don't really have many plans for the future after college. I'll start from college and see what happens there. Yeah, but like I am considering, I've been thinking about it and I've been considering like all those options, like regular software engineering job or like quant or academia. I don't really see anything. I don't really see myself doing anything else.
How about startup? Are you thinking about?
Yeah, that's also an option, but startups, like it's kind of hard to predict. Like that'll happen. Like if I want to found one, like I'll have to have some sort of idea that I think could be big, and like that'll happen in the future. So like I have some brilliant startup idea right now. So I can't really. I'm not sure about that. Like it is something like I'd consider. Like I'm not opposed to it, but I'm like unsure about that.
Okay. Are you continuing to do competitive programming in your senior year? Are you gonna continue doing it?
Yeah, so I'm quite confident I won't give up on competitive programming anytime soon. Because I just find it enjoyable and like I expect to continue in college too, maybe at CPC, and like compete there. Yeah, so as for camp and IOI, I'm unsure still. I haven't decided on that yet, but I'll definitely like keep doing it as like a subject.
All right, thank you guys so much. Does anybody else have any questions? Okay, if not, I'm gonna end it here. Thank you guys. You guys are doing great. I'm so impressed by your achievement, and yeah, I think both are remarkable young men, and we wish you every success in your future endeavors.